This is a video on geothermal heat pump. A geothermal heat pump is a type of system that is used mainly to heat and cool houses and buildings. Solar energy gives heat to the ground. The earth then absorbs approximately 48% of the sun's energy, leaving a fairly constant underground temperature between 7.2 degrees Celsius and 21.1 degrees. If you dig 10 to 15 feet down into the ground, you'll find that the temperature will maintain a constant 16 degrees all year round. So every geothermal system will have three major components: a geothermal heat pump to move heat between the building and the water in the earth connection, and an earth connection for transferring heat between the water and the earth. Finally, a distribution subsystem for delivering heat or cool air to the building. The pictures show the process for heating a building. The heat is extracted from the water in the earth connection by the geothermal heat pump, and then the heat is distributed through a system of air ducts. Cooler air from the building is then returned to the geothermal heat pump, where it cools the water flowing to the earth connection. The water is warmed again as it flows through the earth connection, and for heating the building, the process is just reversed. This is a representation of a geothermal heat pump system. The water circulates through the pipes that are buried underground and absorbs the geothermal heat energy. The water carries the heat and transfers it to the heat exchanger full of refrigerant. The refrigerant is converted into vapor and forced through a compressor. The temperature of the compressed vapor begins to increase due to the decrease in volume. The compressed vapor is pushed into the condenser where the vapor releases its heat. The air is blown across the condenser and pushed through the air duct to distribute the heat into the building. After the refrigerant has released its heat, it is forced through an expansion valve where temperature and pressure drops. The refrigerant is circulated back to the primary heat exchanger again. For the cooling process, the described process is reversed. The heat is gathered from the building and rejected back into the ground. There are several types of configuration that can be used in installing a system. The type selected depends on several factors such as soil type, availability of a water source, the size of the installation, and the amount of land available. Loop may install horizontally or vertically in the ground or submerged in water. There are three types of configuration that can be used in installing a closed-loop geothermal system. The system can be laid horizontally in the ground, or vertically in the ground, or submerged in a body of water, for example, like a pond. A horizontal closed-loop system has the heat exchanger pipes that are laid out in parallel to the ground surface. This type of installation is generally most cost-effective for residential installations, particularly for new construction where there is enough space available. It requires trenches at least 4 feet deep. The most common layout uses either two pipes, one buried at 6 feet and the other at 4 feet, or two pipes placed side by side at 5 feet in the ground in a 2-foot wide trench. A vertical closed-loop system has the heat exchanger pipes that are laid out in perpendicular to the ground surface. For a vertical system, holes are drilled about 6 meters apart and 30 meters to 120 meters in depth. In these holes, two pipes are placed and connected at the bottom with the U-band to form a loop. Typically, 80 to 105 meters of piping can produce a ton of heat, which is equivalent to 3.52 kilowatts. The vertical loops are connected with horizontal pipe placed in trenches and connected to the heat pump in the building. Vertical loops minimize the disturbance to the landscape so they can be used where the soil is too shallow for trenches. Large commercial buildings and schools often use vertical systems. A pond closed loop is a type of system in which pipes are coiled into a circle and placed around 8 feet below the water surface. The minimum depth of the water should be between 2 meter to 3 meter. This type of loop is not a common closed loop because we need a body of water close by. An open loop system is much preferable in this situation, which will be introduced in the next slide. This system is preferred when the pond has poor water quality, which the open loop system cannot be used. The open loop system is also known as the direct system. The system circulates the water that are drawn from the ground or from the surface of the water source. Once the heat has been transferred into or out of the water is then returned to a well or by surface discharge. This option is practical where there is an adequate supply of relatively clean water. The standing column well is a specialized type of open loop system. Inside the system, the water is initially drawn from the bottom of a deep rock well, and then the water is passed through a heat pump. After the heat has been drawn from the water is then returned to the top of the well. While the water is traveling downward, it exchanges heat with the surrounding bedrock. If the water temperature in the well drops too much, a 10% bleed cycle are used to introduce fresh water and regain a little temperature. You can only build a standing column well where there is a near-surface bedrock. The building of the standing column well is not suitable if the ground is composed of mostly clay, silt, or sand. This system can often be applied to both residential area and small commercial buildings. Heat pump moves 3 to 5 times more heat energy than the electrical energy it consumes. To determine the thermal efficiency of geothermal heat pump, we use coefficient of performance and energy efficiency ratio. COP is used to evaluate the heat efficiency. EER is used to rate the cooling efficiency. Here's a table comparing the EER and COP of closed loop, open loop, and standing column well system. The COP in standing column well is the highest, meaning that it is the most efficient when it comes to heating the building. The EER in open loop is the highest, meaning that using an open loop system to cool a building is the most efficient. The U.S. Environmental Protection Agency has actually called geothermal heat pump the most energy efficient, environmentally friendly, and cost-effective space conditioning system available. From the graph, geothermal heat pump has the lowest carbon dioxide emission out of all heating systems. Heat pump can reduce greenhouse emissions significantly. Installing one geothermal system is actually the equivalent of removing 2 cars off the road and planting 1 acre of trees in carbon dioxide reduction. And the heat pump uses the renewable geothermal energy. However, the refrigerant we use in the closed-loop heat pump cabinet is chlorodifluoromethane, which is an ozone-depleting substance. Also, in open-loop system, the drawing of water from a well and draining that water to the surface may contribute to aquifer depletion, water shortage, groundwater contamination, and subsidence of the soil. The cost of installation is affected by the size of living area, the home's age, installation feature, geology of the area, and location of the property. As you can see from the graph, the geothermal has the lowest operating cost. A typical 2,200 square feet residential building requires about 10 kilowatt that will cost approximately $30,000 to $35,000. Capital costs can be subsidized by governments. In BC, the maximum grant a home can receive is $5,000. In general, A homeowner can save 25% to 40% annually on utilities by switching to geothermal heat pump. For example, the McMahon secondary enrichment saved $20,000 every year by switching to geothermal heat pump. So in the long run, geothermal heat pump will actually save money. The table presented here is two examples that show the calculated time to recover the capital cost of the system. Here is a list of the advantages and disadvantages of the geothermal heat pump system. The life cycle is very long. The system can be expected to provide an average of 20 to 24 years. In both commercial and residential installations, geothermal heat pump systems typically have lower maintenance costs than conventional systems because all equipment is installed inside the building or underground. This means that the outside equipment will not be exposed to weather or damages. As we know, the geothermal heat pump can have really low operating costs and is environmentally friendly as mentioned before. Also, the open-loop system have low loss in heat transfer and has lower heat pump energy costs. The system is also very quiet. The disadvantages are that in an open-loop system, the machine parts are needed to be protected from corrosion and are required periodic acid cleaning since they are buried underwater. Over a long time, the chemical in the water can actually make the system difficult to exchange building heat with groundwater. Moreover, the installation capital costs of geothermal heat pump are quite high. Thank you for watching our video.